in a chi-square goodness of fit test, how's the data present to you? So you will get a table, and then in the first column, so let's use my favorite example, course grade. In the first column, you will see course grade, 5 categories, A, B, C, D, and F. And then in the next column, they will give you expected percentage. So let's say in a professor's class, 20% of the people got an A, 30% of the people got a B, 15% of the people got a C, so on and so forth. So in the second column, you will see a bunch of percentages, right? And then in the next column, they will go ahead and then collect a random sample. So let's say 100 students, you have a random sample of 100 students. So within this random sample, you have to find out how many people got an A, got a B, got a C, so on and so forth. So at this point, you have 3 columns. The first column is the categories, A, B, C, D, and F. And then the next column, percentages. And then the next column, you will get observed frequency, right? And then you go ahead, take the sample size, multiply each percentage to calculate the expected frequency. Now, there is a what if. What if you don't have percentage, right? So in this problem, take a look. This problem is about age distribution. So we have 2 cities, city A and then city B, and then within each city, I divide people into age groups. So let's say the first group is 0 to 9, and then 10 years old to 19 years old, 20 to 29, 30 to 39, so on and so forth. So I have 700 residents from city A and then 700 residents from city B, and then within each sample, I divided people into the age group. So it's not dividing. So let's say the first person in city A, that person is 5 years old, then you make a count in the first age group, so on and so forth. So in the first, in city A, we have 10 people age 0 to 9, 20 people age 10 to 19, so on and so forth. So this problem, you do not see any percentages, right? So my question is, do the age distribution in city A fit the age distribution in city B? I want you to carry out a chi-square goodness of fit test. So for chi-square goodness of fit test, what are you trying to do? What kind of question you are trying to ask? You are trying to answer. The question that you are trying to answer, the keyword is fit. So here is the best way to picture chi-square goodness of fit. Just imagine that you are going to a sneaker store and you want to buy a pair of new sneaker. What do you do before you pay? You want to try the shoes on, right? So the result is either a fit or not fit. So I have city A and then city B. The question is, can I fit city A to city B? A fits B, yes or no? All right, so here is the null hypothesis. The null hypothesis is always fit. And then the alternative hypothesis, which is the opposite, that is not fit. Okay, so let's elaborate a little bit. So the null hypothesis, I will write the age distribution, the age distributions in city A fit the age distributions in city B. So the H0 is fit and then HA. So all you have to do is you change the fit to not fit. All right, so that is the H0 and HA. And then in a hypothesis test, after you set up the H0, HA, you know that this is a chi-square goodness of fit. And then you proceed to calculating the test statistics, which is the chi-square, right? So in a goodness of fit test, the chi-square is, so the chi-square that is equals to summation. And then you have observed minus expected, square divided by expected. And then you do this for every single age group. So the first age group from 0 to 9, you have 10 minus 21 square divided by 21. And then you have 20 minus 48 square divided by 48. And then you have 120 minus 50 square divided by 50. And then you have 250 minus 66 and then square divided by 66, and then you keep on going until you reach to the last group, 36 minus 170 square divided by 170. and then that is approximately equals to a number. Of course, we don't do this one by one. We will be using the chi-square goodness of fit test in our TI graphing calculator to do the rest of the work. But before you do that, let's take a look. So CTA and CTB. So CTA, if you just take a look at the data, I can see that majority of the residents, they are within 20 years old. They are aged 20 years old to 49 years old. And then in city B, I see that majority of the residents, the biggest numbers, they are right over there. So they are in the older age group. And you are trying to fit city A to city B. So when you are trying to do the fitting, can you fit 20 to a 150? Can you fit a 250 to a 66? Can you fit 123 to 115? Just imagine this. This is the size of your foot. This is the size of your shoes. Does that fit? No, right? So most likely, this is not going to fit. So let's find out. And then to do the work in your graphing calculator, so you take out your calculator, and then the first place that you will have to go follow the screenshot, you have to click the stat key, and then you will see edit immediately. Click on that. So in case you still have old data from the previous problem, you have to move the cursor all the way to the top of the list. So let's say L1, you move the cursor all the way to the top and then hit clear, and then you hit enter. So that erase the entire column. All right. And then you enter CTA to L1 and then CTB to L2. Now the data is finished. After the data is finished, you hit stat again. So this time you will hit the right arrow to go to test. So stat, hit the right arrow to go to test, and then you go down to find chi-square GOF test, goodness of fit. The chi-square test is for test of independence. And then you click goodness of fit, the GOF. Your observed is in L1, your expected is in L2. The degree of freedom, we have 8 groups, right? So you take 8 minus 1, and then you are ready to calculate. So once you click calculate, you can see that the chi-square is approximately equals to 784. So 784.131, right? And then the p-value is extremely small. The CNTRB, the first one is 5.76, right? So if you take 10 minus 21 squared divided by 21, you will get 5.76. So that's what the CNTRB is for. Okay, let's report the p-value. So the p-value, let's do it right here. So the p-value is 0, so that is less than 5% alpha. So therefore, we reject the null hypothesis, right? So therefore, we reject H naught, we reject H naught, then and HA is true. So we reject H naught, then HA is true. Then what do we say? Since HA is true, so that means that is a not fit. So that means the age distribution in city A do not fit B, right? So A do not fit B. So the distribution of A do not fit the distributions of B. Not fit. Just like what I said. Because you cannot fit a 250 to a 66. Alright? Okay, what about the graph? So if you click the graph, goodness of fit is right-sided, and then you have the chi-square, the test statistics, 784. The graph starts at 0 in the origin. So 784, that is so far on the right, and since this is a right-sided, the p-value on the right side of the cut is extremely small. So I would like to give you a more discussions on this. How do you calculate the chi-square statistic? You take observed minus expected divided by expected, right? So let's take a look. How about this? I am going to look at the last pair, 36 and 170. So the way you do this is you take 36 minus 170 and then square, you divide it by 170, right? So this is observed minus expected. Now, let's do a comparison. How about this? What if, just a what if you have a 171 minus a 170 divided by 170? Now, without doing any math, tell me this, just use your common sense. 36 fits 170 versus 171 fits 170, which one is a better fit? The answer is 171. If you compare the value, this is a 1 square divided by 170. So 36 minus 170, you have a negative 134. So this is a negative 134 square divided by 170. Which quotient is big? Which quotient is small? The answer is, of course, this quotient is big because the denominator is huge. So this quotient is big, and then this quotient is small, right? Now, you are not only have one quotient. In this problem, you have how many? You have 8 quotients, right? You have 8 fractions added together. So you are doing the sum of big fraction. What happened to the sum of a small fraction? Which sum is bigger? The answer is, this is bigger, right? So this one, you have a big chi-square versus a small chi-square. Okay, and then we draw a graph. So let's draw a graph right over here. And then here is the graph, chi-square. The chi-square starts at 0. So where is the big chi-square? The big chi-square is right over here. So this is big. Since this is a right-sided test, then the p-value is very tiny. In comparison, for small chi-square, so you have a small chi-square right over here. So this is a small chi-square. And then since this is a right-sided test, you have a big p-value. Okay, so big p-value, that means most likely that is a fail to reject. So this one is a fail to reject. And then this one is a reject, right? So you reject H0 and then HA is true. So that means this is a not fit. And then this fit, I'm not going to say fit, this fit remains suspicious. So not fit, of course, 36 not fit 170, and then the suspicious, maybe 171 fits 170, maybe, right? Suspicious. Okay, so that's the concept of big chi-square versus a small chi-square. Okay, let me do one more thing really quick. The p-value, so if you don't want to, if you do everything by hand, you have 784, you want to calculate the p-value. So how do you calculate the p-value? You go to second VARS, you hit the second key, and then you hit the VARS key. You go down to find chi-square CDF. CDF stands for cumulative density function. That means finding the area under the curve. The PDF is finding a point on the curve. So pick CDF, and then the lower limit is your chi-square. The upper limit is positive infinity. The way I type that is, I type a 1, and then I type a second comma, did you do that? And then a 99, so you have a 1e99, that means 1 times 10 to the 99, which is infinity. You have A category minus 1. Once you hit the paste, you paste the whole command to the home screen, click enter, you get your p-value. And then if you're using an older calculator, they will start with a chi-square CDF. They will start with this, a chi-square CDF, and then they will open the parenthesis for you. So in that case, you just type the chi-square and then a comma, the positive infinity, and then type the degree of freedom, close the parenthesis, press enter to get your p-value. Alright, so that is the end of this video. If you like it, you think this is helpful, give me a like, share, and subscribe, and I will definitely see you all in the next one. Signing out.